Hello, everybody. So, this is the first lecture after a long time in the mathematical physics series. Today, we are going to talk about scalars and vectors, some preliminary concepts which will be useful for you if you remember them, as they are the basic properties of these two constructs in mathematics. So, let us discuss what are scalars and vectors. We'll begin with scalars. So, how do you describe scalars? Scalars are quantities, mathematical quantities, constructs that have a magnitude, a value only, only a magnitude. For example, if you have a number uh, uh, 0, 1, 2, 0.5, 0.56, under root 2, or pi could be an integer value, could be a negative value, could be a negative real number, rational number, irrational number. So that is the magnitude of a scalar. So scalar is just represented by a magnitude. And of course, there is a unit. For example, if you talk about mass, let us say approximately your mass, it should be around 50 kg, 60 kg, let us say 50 kg. So kilograms is the unit for mass. Mass is a scalar quantity, it has a magnitude in kilograms. Then we can talk about distance, such as 2 kilometers. Let us say I tell you walk 2 kilometers around a field, round 2 kilometers, walk for 10 minutes. Even 10 minutes, here 10 minutes, which is a time, is a scalar quantity. Then we can talk about similar to distances, we have height. Let us say you are 162 centimeter tall. Then your height is a scalar quantity. It has a magnitude 162 and its units is centimeters. Of course, we can convert it into meters, then we can say your height will be 1.62 meters. Alright, so these are some examples of scalars, very simple concept. Now we move forward and we'll talk about operations on scalars. So the four basic operations which you know, the first is we can add two scalars, addition. We can subtract two scalars. We can multiply or we can divide. So addition, subtraction, multiplication and division. Alright. Of course, when you do addition and subtraction, uh, let us first talk about the example. Let us say you have two apples. Each weighs 200 gram. Then you can add these two quantities for the masses of the two apples. So 200 gram is the mass of an apple. So 200 gram plus 200 gram can be added together and you can get 400 gram as the total mass of both the apples. So you are adding two scalars. Similarly, you can subtract. You can subtract your height from your friend's height. Let us say your friend is 160 centimeters tall. So then if you subtract 160 from 162, you will get a value of 2 centimeters. So here the important thing is when we add or subtract scalars, the unit is important. Both sides should have the same units. If you have kilogram on one side, you should have kilogram on the other side. If you have gram on one side, you should have gram on one side. If you are talking about centimeters, subtracting heights or distances, you should keep the unit same, even their order same. So you cannot subtract centimeter from meters. You first convert centimeter to meters or meters to centimeters and then do the addition or subtraction. So now, can we add two different types of scalars? No. Can we add mass and distance? So we have mass, let us say 50 kg. Can we add it to 2 kilometers? No, we cannot. Alright. So we can only add or subtract quantities with same units. But we can definitely multiply or divide scalars having different unit. For example, uh, we can divide distance, which has a unit of, let us say, meters, by time, which has a unit of seconds, and this gives us a new value, which gives us sorry, I have written velocity here, it should be speed. So we uh, can we add scalars having two different units? No, we cannot, but we can multiply or divide scalars having different units. For example, if we have a scalar which is distance, let us say you have run 2 kilometers in 20 minutes, or let us say you have run 2000 meters in 400 seconds, then we'll get a speed. If we divide 2000 meters by 400 seconds, we'll get a new quantity which is also a scalar speed, and its units will be meter by second. So you can think of other such examples. For example, you can think about force. Force is mass into acceleration. So both of uh, mass is a scalar quantity. The magnitude of acceleration is also a scalar quantity, although acceleration is a vector about which we will talk later. But and force is also a vector. But if we just talk about the magnitude, we can say the magnitude of force is equal to mass into the magnitude of acceleration. All of these are here scalar quantities, and you can multiply them. You can also please try to think of other such examples as well. Take it as a homework exercise. Now let us move on to vectors. So these are more interesting because they have, just like scalars, they have a magnitude, and additionally they also have a direction. For example, we talked about distance in kilometers or meters. So distance is a scalar. How much distance you have traveled moving around in a circle, or even if you move in a straight line, you have covered some distance. So this is a scalar. But when we talk about its vector cousin, displacement, displacement is a vector because it has a magnitude, how much distance you have traveled, a scalar quantity, and it also has a direction, in which direction you have moved that much distance. So magnitude, as I have written over here, is an indication of how much to move. It's a scalar quantity, right? You have already it's, and then we have a direction associated with that magnitude, an indication of where to move. For example, consider this diagram over here. Let us say initially you are at point A. Okay, consider you are standing on a football field which is a rectangle given by A, B, C, D. This is actually not a football field, but because the units here are of 1 meter, 2 meter, football field is much larger. Consider you are on a square rectangle, on one corner of a rectangle, whose side AB is 2 meters and whose side AD is 1 meters as shown in the figure. If I tell you that you have to move in the direction of the line AB but only 1 meters, then you will reach a point P which will lie on the line connecting the points A and points B, right? So, as you can see on the right, I have given you some directions. I have written north pointing upwards and east pointing, let us say, rightward towards our right. So, let us say east is in this direction towards our right, and north is towards the upward direction of the screen. So, what we are doing is when we are moving from A to P, we are moving 1 meter along the line AB, which is also which also lies along the direction east, right? So we can say AP is a vector which indicates we have moved 1 meter in the direction east as shown as written over here. Then if I tell you to walk from a distance 2 meter towards east, where will you reach? You will reach point B because B is the point which is in the east direction from point A and exactly at a distance of 2 meters. Alright, if I tell you you move from the point A to point C, you will move a distance of under root 5 meters, which we get from the Pythagorean theorem. Considering angle ABC is a right angle, of course, because it is a rectangle, angle ABC is a right angle. So if you calculate the value of AC, you will get under root 5 meters. So we say that AC is a vector where you have covered under root 5 meters, square root 5 meters towards the direction of point C, as written over here. Similarly, you can talk about a vector AD. So AD will signify that you have moved 1 meters towards the north direction from starting from point A. All right. Now these vectors AP, AB, and AD are very simple. These are actually, as you'll see later, examples of one-dimensional vectors. What do you mean by one dimension? You know our space has 3 dimensions, uh, and this screen has only 2 dimensions. So for example, here we have said we have a direction east and we have a direction north. The direction east represents the direction along one of the dimensions uh, on the screen, and the direction north is the direction along the uh, direction. In the direction north is perpendicular to the direction east, orthogonal to it, and it is upward, so it is the second dimension basically. So this is a two-dimensional case, but point AP, point AB, they only lie along the east direction. So we can say they are one-dimensional vectors because we can just quantify them by the quantity, how much they have traveled in the east direction. Let us say I say 1 meters towards the east, so I just need to give you, I can just say 1 meters. If we are only talking about, if we know we are only talking about the east direction, we are not considering the north direction for the time being, then I say walk 1 meters. So we are talking about the one dimensional case along the east direction. So we reach P, and then if I say walk 2 meters from A, of course along the east direction, you just need to specify the magnitude. Direction is implicitly understood that it is along the east direction. So you will reach AB. So this is a one-dimensional vector. Similarly, if I say, if I consider only the movement in the north direction and I tell you to move 1 meters, you will reach point D along a straight line. But how do you reach point C? I said move under root 5 meters towards point C. But the line AC is neither along the north direction nor is it along the east direction. So how do we specify this movement from point A to point C using vector, the concept of two-dimensional vectors? So look at this diagram. What we can see is, let us say the point A is given by 0 meters, 0 meters. 0 meters movement in the east direction, 0 meter movement in the north direction. And the point B is given by 2 meters movement from point A in the east direction and 0 meter movement from point A along the north direction. Basically what we are doing is, if we are moving from point A to B, we are only moving 2 meters in east. We are not moving along the north direction at all. But for C, what we do is, for point C, we can say we first move from point A to B 2 meter east, as shown over here, and then we move from point B to point C 1 meter north. So now we have given you, now we have two quantities. To reach point C from point A, we first move 2 meters to point B, and then from point B we move 1 meter upwards along the north direction to reach point C. So if we replace our north and east direction by unit vectors basically tell you about the directions. They we will see about this later. Just consider them to be directions. So we have two unit vectors, x cap and y cap. So x cap tells us, let us say, to move towards east. Y cap tells us to move towards north. Then we can say to move from A to C, we move 2 meters along x cap direction and 1 meters along y cap direction. So AC vector with an arrow on the top is equal to 2x cap plus 1 y cap in meters. Unit is very necessary to be mentioned. You should always take care to check your units. We can also represent, since in our coordinate system on this plain paper we know which direction is x cap, which direction is y cap, we can simply write our AC vector as 2 comma 1 in brackets, and outside we'll write the unit meters. So basically we have now specified what our vector AC is. It has two quantities, along x cap direction and one along y cap direction. So it is an example of a two-dimensional vector, and as I have already talked, one-dimensional vector is AB and another one-dimensional vector which we have considered is AD. So what about vector CA, vector BA and vector DA? What if I tell you to move from C to A, or from B to A, or from C to B, or from D to A? How do we do that? What we simply do is we just walk in the opposite direction, right? So if x cap is positive towards the right hand side, if we move in the opposite direction, we say we have moved in the minus x cap direction. And if we move opposite to the y cap direction shown in this figure, let us say towards the downward side, we say we have moved along the minus y cap direction. So if I tell you to move from C to A, we will talk about a vector CA vector. So we have moved 1 meter towards the minus y cap direction if we want to talk about the CA vector. So we have moved from C to B along the minus y cap direction 1 meters. Then we have moved 2 meters along the minus x cap direction from B to A. Then CA vector will simply be given by minus 2 x cap minus 1 y cap meters, or minus 2 comma minus 1 meters. Exactly the same values as for AC but with a minus sign, because of course this CA vector will be pointing opposite to AC vector. Alright, I hope this is clear to you. Now we'll move to the section about vector addition. Can we add vectors? Yes, we can, if they have the same units, of course. Similarly, we can also do vector subtraction. And this addition and subtraction will be done component wise. So for example, if we talk about the vector AC and we talk about 2 comma 1 meters inside brackets, these 2 and 1 are the two components of the vector AC. Similarly for CA vector, minus 2 comma minus 1 are the two components of the CA vector. So what we do is when we add each component. Let us say we have to add CA vector with AC vector. So what we will do is we'll add 2 with minus 2, which will give us a 0. And then we'll add 1 with minus 1, which will again give us a 0. So CA vector plus AC vector is 0 comma 0 meters. Of course, it will have to be, because this means we have moved from AC to CA and then back to from C to A. That is, we have come back to our original position, 0 comma 0 meters. Can we do vector multiplication? Yes, we can do vector multiplication as well, and with different units, but we have a more complicated, not a difficult, a little complicated system of vector multiplication, component wise multiplication, and we'll talk about this in our next lecture. We'll talk about the dot and cross products. Okay, next thing is, can vectors be added to a scalar? No, we cannot add a vector to a scalar, but we can add a two-dimensional vector to a one-dimensional vector, because even the one-dimensional vector will lie along one of the two component directions that the two-dimensional vector consists of. So we can consider a one-dimensional vector to be actually a two-dimensional vector with one of the components being 0. Can a vector be multiplied with a scalar? Yes, a vector can be multiplied with a scalar. Basically, when you multiply a vector with a scalar, you multiply each component with the same scalar. So if you say you multiply vector AC with the scalar 4, so what you will do is 4 into vector AC will be 4 into 2 x cap plus 1 y cap, or 4 into 2 comma 1, which will give you a new vector, that is 4 into 2 x cap plus 4 into 1 y cap, that is 8 x cap plus 4 y cap, or 8 comma 1, 8 comma 4 meters. So these are the simplest concepts about the scalars and vectors and their addition and multiplications. You should practice some questions about this, and if you have any problems you can leave comments to this video. I'll be very happy to add my own opinion and answers to those comments. So feel free to comment constructively, and just carry out your own example questions. Do your own example questions. Practice some problems. Uh, because when we talk about mathematical physics, the most important things uh, are practice and practice. Because of mathematics is a language. It is like you are learning English or Hindi or any other language. Let us say I speak Hindi and English, that is why I talked about that. But uh, if you talk, when you're learning a language, you just don't get it in one go. You practice it, you practice speaking it, even though you may not understand the grammar, but you can speak it if you practice it consistently. That's how you learn when you are a child. You do not know anything about grammar, but you know how to speak it. So that is one way, and that is an important way of understanding how to do maths. It is the language of science and technology, and it is the language of the universe. So practice and practice. I leave you with this message about practicing yourself, not depending on um, videos or classroom questions to understand concepts. The best person who will help you understand your concepts is you yourself. So we'll discuss more about vector multiplication in the next video, and I leave you with that. Have a nice time.